Hello students. In today's class we shall discuss about pericyclic reaction. Now let's learn about pericyclic reaction. There is an important class of chemical reactions which are insensitive to the presence of polar solvents and catalysts and do not involve ionic or free radical intermediates. So, there is an important class of chemical reactions which are sensitive to the presence of polar solvents and catalysts and do not involve ionic or free radical intermediates. Such reactions following a concerted mechanism involving simultaneous bond breaking and bond making and proceeding via cyclic transition state are called pericyclic reaction. Woodward and Hofmann have suggested the pericyclic reactions for those which are concerted, that is, bond breaking and making takes place simultaneously. And the next is involved electron shift in cyclic manner. These two are the rules which is given by Woodward and Hofmann. Next, we study about characteristic features of pericyclic reaction. What are the characteristic features of pericyclic reaction? First one is they require only heat and light for initiation. They require only heat and light for initiation. Next one is mechanisms do not involve any free radical or ionic intermediate. The next one is the mechanisms include a cyclic transition state. Another one, the reactions are highly stereospecific and stereoselective. The other one is the rate of reaction remain unaffected by change in solvent polarity or by presence of a radical initiator or inhibitor or other catalyst. And the last one is the reactions are reversible though the equilibrium often lies well over to one side or the other. All these are the characteristic features of pericyclic reaction. Now, there are four types of pericyclic reaction. What is this? These are electrocyclic reaction, cycloaddition reaction, sigmatropic reaction and cheletropic reaction. These all are pericyclic reaction. Many approaches have been made to explain the stereochemical results of pericyclic reactions. There are three approaches by which the stereochemical aspects of pericyclic reactions can be explained. They are conversion of orbital symmetry, frontier molecular orbital approach, or this is known as FMO approach. And the next one is the aromatic transition state concept, and this is known as HMO concept. These approaches have been made to explain the stereochemical results of pericyclic reaction. Next is characteristic features of electrocyclic and cycloaddition reaction. What are the characteristic features of electrocyclic and cycloaddition reaction? Electrocyclic and cycloaddition reactions have the following common characteristic features. They involve interconversion of pi and sigma bonds. Next one is they require only heat and light for initiation. Their mechanisms do not involve free radical or ionic intermediate. Bonds are made or broken in a single concerted step involving a cyclic transition state. The reactions are highly stereospecific. These are the characteristic features of electrocyclic and cycloaddition reaction. Now we study about electrocyclic reaction. What is an electrocyclic reaction? Is concerted interconversion of conjugated polyene and cycloalkane under the influence of heat or light. Here we take this compound. Now this bond attacks from here to here. This bond shifts from here to here, and this bond shifts from here to here. Now in the presence of heat or H nu, we get this product. Now here we take butadiene. Now in the presence of heat or H nu, we get this product. This bond breaks from here to here, and this bond shifts from here to here. This is all about electrocyclic reaction. Now we shall study about bonding molecular orbital. What is bonding molecular orbital? Half of the molecular orbital having lower energies than the isolated p orbitals are called bonding molecular orbitals. Next one is antibonding molecular orbital. What is antibonding molecular orbital? Half of the molecular orbitals having higher energies than the isolated p orbitals are called antibonding molecular orbital. Two molecular orbitals which are of particular importance in understanding pericyclic reactions are the occupied molecular orbital of highest energy, termed the highest occupied molecular orbital. These two molecular orbitals which are of particular importance, the first one is the highest occupied molecular orbital, and this is known as HOMO. And the next one is the unoccupied molecular orbital of lowest energy, termed the lowest occupied molecular orbital, and this is known as LUMO. The HOMO and LUMO are termed frontier orbitals because they are the molecular orbitals at the energy extreme. Now we shall study the explanation of electrocyclic reactions by FMO approach. Here we take this compound. In the presence of heat, we get this trans isomer, and in the presence of H nu, we get this cis isomer. Here we take this compound. These two are p orbital. Now this p orbital rotates from here to here, and these p orbitals rotate from here to here. So this p orbital rotates clockwise and this p orbital rotates anti-clockwise. So this is a dis-rotatory motion. And these p orbitals are HOMO of the ground state and psi3. And for this dis-rotatory motion, we get this. For this p orbital rotate from here to here, so this CH3 gets upward and this H gets downward, and we get this. And for rotating here to here, this hydrogen gets upward and this methyl gets downward, and here a bond is breaking. And as a result, we get this trans isomer. We take this compound. This is Psi4 star and HOMO of excited state. This p orbital rotates from here to here, and this p orbital rotates from here to here. So this bond also, this bond and this bond, these two, this p orbital and this p orbital rotate clockwise. These also rotate clockwise and these also rotate clockwise. So this is called rotatory motion. In the presence of H nu, we get, for this rotation, CH3 get upward and H get downward, and for this rotation this CH3 get upward and H downward, so we get CH3 CH3HH, and here a bond is making, and as a result we get this compound. This is the cis isomer. So student, this all about electrocyclic reaction. In the next class we shall study about cycloaddition reaction and sigmatropic reaction and cheletropic reaction.